So I ran out of time in the last video, so I'm going to just kind of explain what I was in the middle of explaining in that last video. So when we look at number 4, we see that y equals 0, x equals 0. So when we go to draw those, and we draw the x and y plane, we already have those points laid down, right? If I'm looking at the y-axis represents where x equals 0. Notice that all along this line, x never moves. X is always 0. I could go all the way up here, and x is still going to be 0, even though y is like 100 or something like that. Same is true about down here. If we're looking at the x-axis, y stays 0 all along this line, okay? So that's how I know what I'm drawing here. One of these represents y equals 0. The other one represents x equals 0, okay? So we have to ask ourselves, are these two parallel? Well, no, they break the number 1 rule, which is they intersect. In fact, I went ahead and circled where they intersect. So you could say no, and your reasoning could be that they intersect, or you could just say that they are perpendicular. So notice that where they're intersecting is obviously a 90-degree angle, if we know that this is the x and y axis, right? So they're crossing at 90-degree angles. So we know that these are actually going to end up being perpendicular. And we'll just save that information for later when we go to do the next 5 problems. Okay, let's look at number 5. So number 5 is very similar to number 3 because when I go to draw kind of a rough diagram for this, right? And I count over, and I'm trying to graph now x equals -4. Remember, I'm just doing a rough graph just to get the idea of what's happening here. I'm not being super accurate. Let's just say these go up by 2. So 1, 2, 3, 4. So we've got a line at x equals -4, right? And then we've got a line at x equals 1. Remember that those are going to be vertical lines, okay? So if these are vertical lines, and we know that all along these lines, x is forever going to be -4, x will never be able to be 1, which means these two lines are never going to cross each other, right? And you can even visually see that the answer is yes, these are parallel because they'll never intersect. And the reasoning why is because both are perfectly, if you're paying attention, you should realize what you're going to write here. Not horizontal, but vertical. Okay? So both are perfectly vertical. All right. So just as a general rule of thumb, you don't need to draw these examples every time. But you do need to be able to give some kind of explanation as to how you know that they're going to be parallel, right? So for example, number 3, you don't even have to draw the graph if you already know visually in your head that these are going to create 2 horizontal lines, right? You don't even have to know where exactly they're going to be. You just know that they're going to be 2 horizontal lines, so you know they're never going to cross each other, right? So your answer has to be that both are perfectly horizontal, which means they'll never intersect, okay? Number 4, you're going to say, no, they're not parallel because one is vertical and the other one is horizontal. Since one is vertical and one is horizontal, that means inevitably, even if they start out over here and over here, inevitably as they keep traveling, they're going to intersect eventually, right? And then number 5 is very similar to number 3. Okay. All right, let's go ahead and do page 57, number 7 through 11, all. So you can pause the video and then come back. Okay, let's do this one together. So these are the last problems here. So looking at number 7, I'm going to count out, just like we did before, I'm going to count this out and figure out what the slopes are for these lines. So if I'm looking at the blue line, it goes up 1, 2, 3, 4, 5, 6, but over 1. So if it's up 6 over 1, I know that I have a slope of 6 over 1, which you don't have to write the over 1 part. It's just 6. Red, you go up 1, 2, 3, 4, 5 over 1. Okay. 5 over 1. And then green goes down 1 over 1, 2, 3, 4, 5, 6. Okay, so now down represents -1, and to the right, 6. Okay, so remember, we're checking to see if these are perpendicular now. So we're not checking for same slope. We are checking for opposite reciprocals, okay? So I need to do a little bit of work off to the side to figure out what are opposite reciprocals. Well, I think the one that doesn't fit out of these three, just by looking, it's easy to tell that the 5 doesn't fit, right? So I'm going to assume that blue and green are my answers here, but can I show that they are opposite reciprocals? So if I'm taking 6 and I'm trying to change it to an opposite reciprocal, I'm going to check. Does 6 have the opposite sign from -1/6? Well, this is a positive number, and this is a negative number, so yes, it meets the opposite, right? What about reciprocal? Well, I know that 6 is the same thing as 6 over 1. If I were to flip that and find the reciprocal, I would get 1/6. Is this 1/6? Yeah, this is. This is -1/6, which means it's an opposite reciprocal of 6, which means the reason why these are perpendicular is because they have, and we'll just abbreviate, op, recip, or rec slopes. That's my reasoning here, okay? And that's what you're going to say each time for these, okay? Now let's do number 8. So number 8, I'm looking at the blue line. I'm going to count, go down 1, 2, and to the right, 1, 2, 3, 4. So I've got a slope of down 2 over 4, which is the same thing as -1/2. Okay, if we simplify it. Now let's look at red. Red, I go down 1, 2, and I go over 1, 2, 3, 4. Same story, so I'm just going to go ahead and assume that this is 1/2, right? And then, is that true though? Let me double check that. 1, 2, 2, 3, 4. Okay, perfect. I was just checking. That's kind of an oddity, so just wanted to check. Okay, so green goes up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. Okay, so if it goes up 6 over 3, so far this isn't looking like an opposite reciprocal situation until we realize, oh wait, this simplifies to 6 divided by 3, which is 2. Okay, so now I have to ask myself which of these are actually going to be perpendicular to each other. Well, I know red and blue aren't perpendicular because they have the same slopes, so that's not going to work. But I did find out that blue and green match. So blue and green are perpendicular. But then I also noticed that red and green are also opposite reciprocal. So in this case, I have 2 answers. And that totally makes sense. If these are going to be the same slope and they're both crossing this, one is crossing it at a 90-degree angle, it would make sense that the other is crossing at a 90-degree angle, right? And so my reasoning here is the same as last. They have opposite reciprocal slopes, okay? And let's just check that claim because we're saying it, but is it true? Well, it is, because -1/2, if I were to flip -1/2, so let's take -1/2 and let's flip it and change the sign, right? It's going to change to positive 2 over 1, which is the same thing as 2. And that's exactly what we have for green here, okay? So we know that they are perpendicular. Okay, let's talk about number 9 through 11. So number 9 through 11 is the same kind of problems we were dealing with before. except now we're going to get kind of opposite answers. So first off, let's go ahead and take a look at number 9. And like I said before, I'm just going to kind of draw a rough estimate of where these lines would end up. So if I'm looking at number 9, x equals -2 is going to be somewhere along the lines of this, right? So I'm going to draw it kind of like a dotted line. And we know that that's a vertical line. But if I'm looking at y equals 8, we know that's going to be a horizontal line. If these two lines are both perfectly horizontal and perfectly vertical, we know that they are crossing at a 90-degree angle. And so the answer here is yes, these are perpendicular. You need to pay attention to which one you're doing, perpendicular or parallel, okay? Now let's look at number 10. Number 10 is kind of the opposite story. Here we've got x equals -8 is going to be out here somewhere, and x equals 7 is going to be out here somewhere. So if that's the case, these two lines are not crossing at a 90-degree angle. In fact, they're never going to cross at all. So the answer here is no. And then let's look at number 11. Number 11, we've already seen this before. In fact, I don't even really need to draw it because it's already drawn up here at number 4, right? So number 11, if I'm looking at this, obviously these two are crossing at a 90-degree angle because that's what I wrote before. So the answer for number 11 is yes. Okay? And that is 2.2 extension.